In this video, I'm going to explain an ALP 8051 ALP assembly language program to add the byte present in RAM location 34H and 35H and store the result in register R5 and R6. So LSP we have to store in R5, MSP you have to store it in R6. So let's start. ORG 000, it defines the start of the program at location 000. Move R0 hash 34H. You can write 0x34. You can write 0x34 hexadecimal, or if you want, you can write 34H also. Both are correct. So it indicates we are loading or not, we are moving or not with immediate data of 34H. So actually, it is actually holding the address of the data which is present in 34H. So we have to add 34H content and 35H content. So first you have to load the 34 address in R0 and initially assume that carry is actually stored in R6. Okay, if you add 8-bit 8-bit, suppose if carry is generated, you have to indicate that in the register R6. So let us assume that initially carry is 0. After that, here we loaded move R0 with 34H. Next we have to, so let me write this line next. So that first one is carry. Move R0 with 34H. Now move A, comma address at symbol R0. So that means at symbol, wherever at symbol comes, it will take the content of the address present in the R0. In the R0 we have 34H. So 34H content is moved to accumulator A. After that we have to add it to 35H content. No? So you have to increment R0. So R0 is incremented by 1. So R0 previous value is 34. 34 plus 1 is 35H. So now R0 value is 35H. And now move B comma at R0. So now B comma at R0 means R0 is 35H. Content of 35H is moved to B. After that, we have an instruction to add. We have add A comma B. So it is going to add content of A with content of B register, and answer is again stored in the accumulator. So A is equal to A plus B. You can write small letter or capital letter. A means accumulator, B means another register B. So now we are adding some 8-bit data present in 34H with another 8-bit data present in 35H. So there may be a chance of getting carry. So you have to check the carry by using conditional statement like JNC. Jump if no carry. J means jump. Jump to the label skip. Jump to the label skip if no carry. That means you have to skip this line. You have to skip increment R6. R6 is initialized to 0. Initially carry is 0, no? So no need to increment this. Okay. Next, skip here. No carry means it is skipping, no? So here you have to write. They are asked to store the result in register R5. So we have to, from your answer is still in accumulator because A is equal to A plus B. So add A comma B means A and B will be added and answer again stored in the accumulator A. So from the accumulator, you have to move. So syntax of move is move comma destination comma source. So from A, it is moved to R5. So answer is moved to R5. And if suppose if there is a carry, then you have to increment R6 so that register R6 becomes incremented by 1. So 0 becomes 1. Otherwise, what you can do is if there is a carry, okay, so you can avoid this line also, can avoid this line also. And what you can do is here you can write move. So if there is a carry, you have to increment 6. No, so I'm directly writing move hash 1. Okay. So you have to increment, you have to indicate that carry in R6. So R6 is loaded with 1. So 1 in hexadecimal and decimal both are same. So we can write like this. If there is a carry, okay, if carry results in carry, okay, then move R6, okay, move R6 with 1, or you have to load R6 with 1. So that indicates that carry is generated. So we can avoid one more line here. So after that, short jump to exit. The exit means label is this one. So it will infinitely, it will jump to this line only. So this is actually logical end of the program, and last statement end is actually physical end of program. So now I'm going to add this file. So if you want to add new file, add a new item, select ASM file and type this program. Else I already have a program, so you can have add existing programs also. So 23, 24, 8051. I am going to add 8-bit data. So now this program is added here. So now build this file, check for any errors. This is a build output window. So it is showing 0 errors, 0 warnings. Okay. Here back is there. This is required or not. For this, I think back statement is not required. Necessary, don't put any. JNC skip is there. So back label is not required. So I removed that also. So save this. Once again, build the okay. Okay. Now you have to add 34 content and 35 content. So the debug, the debug, declare star debug. So after that, you have to open memory window. So 4 memory windows are available. Memory window 1, 2, 3, 4. I am selecting memory window 1. See here, it will open. I opened all the memory windows. You can see here. So you can drag this and you can adjust the length. Okay, in the memory window 1, so 4 memory windows you can open like this. If you click this, all are on only. Okay, if you don't want this, remove it. So wherever it is orange color is highlighted, then it is open. Okay, now I'm opening, see here, only now 2 memory windows are there. So memory window, yeah, you have to type capital D, okay, colon 0x34h. 0x34 means will show 34h. 0x means hexadecimal 34. So here you have to give some two data. I am giving modify the data. I am giving 57h hexadecimal, comma. Next data is 32h. 57 and 32h. See, both are modified. Or you can double click and you can change the value also. Each one you have to double click and vary. Otherwise, you can directly type the starting address, right click and using comma, you can give continuous data for locations. So in 34h we have 57 and in 35 we have 32. So we have to add those two and we have to store the answer in 35 in R5 and R6 we have to store. If you want, you can store in the next two locations also. I will show that also. So let me start step by step execution. You have to press this step over. So move and you have to click this is a project window tab. This is register tab. So click on register tab. You see R0 is loaded with 34. Then move a comma R0. The content of 34h content is 57. See the memory window 1. So 57 is moved to accumulator A. This is a register A, B. 57 is moved here. Next, it will increment R0. R0 will be incremented by 1. It is highlighted with blue color. Now, move B, at R0. So B is loaded with 32. This 32 is moved to B. B is highlighted here. You can see in the register. Now add A, B. The pointer is here. Still it is not executed. If you give step over, it will add A and B. Answer will be in A only. So 57 plus 32. 57 plus 32 is 5. 7 plus 2 is 9. 5 plus 3 is 8. It is hexadecimal addition. So 89 is coming. Okay, that we have to load it to. So now you have to check for carry or not. If there is a carry, you have to increment R6 by 1. Else, when you restart, already move R6 is will be loaded with 0 only. Okay. See here by reset, all the registers are 0. Whenever you carry is there, you have to change the R6 by 1. Otherwise, you can add that initially move R6 is equal to 0 also. You can add one more extra line in the beginning. Okay, now no carry. So it will go to the label skip. The carry flag is 0. PSW means program status word. This carry flag is 0. So no carry means it will skip to the label skip here. So it is coming here. It is not executed. Move or not R6, 01 is not executed. So now from the accumulator move to R5 because in the program they ask you to store the result in R5. So in R5 you're going to get the sum and in R6 carry is 0 only. So this is the output. So now I'll show you one more with carry. Once again we'll target start debug. Then I'm giving higher value so that you can see. So you can double click and you can give the higher value also. Okay. You can give some A5 8 5 A5 and 8 5 I'm adding. Okay, that you can see the carry also now in R6 you will going to get. So 34 A5 is coming in accumulator. Increment R0, A is incremented to 35, B is 80, B is 85. If you add both, okay, answer is coming 2A is coming in the accumulator and carry is also generated. See here, carry is also generated. So if carry is there, you have to move R6 with 1 also. See R6 is 1 and this is sum. Answer is 1 2A. You can verify the answer using calculator also. Go to hexadecimal. I added A5 with 85. Answer is 2A is coming here in R5 LSB and 1. 1 is carry which is in R6. Okay. So this is how to, if you want, you can store the answer in next two locations. So here you can store, here you can store carry and here you can store, sum and here you can store carry also. So that for that, if you are interested, you can see this video continuous. Those are not interested, you can stop here only. So I'm going to modify this program so that you can store the answer in the memory location also. So here after adding A comma B, your answer is in A only. Okay. So what you have to do is you have to add two more lines. Increment R0. So you have to increment R0 and you have to store the increment R0 and you have to store accumulator content to that location. So at R0 comma A. So I incremented R naught so that the next location I want to store the sum. Okay. If there is a carry, then we have to store that answer in that location. No? So we have to use increment R naught. Again, from R6, you take it to accumulator. Okay, move A comma R6 means R6 content will be loaded to A. And after that, you can store move at R0, comma A. Understood? Here, after addition, increment R0 so that 34, 35 becomes 36 now. In 36, we are storing LSB of sum. And in the carry, again, we are increment R0. R6, we have that carry 1. Directly, you cannot store from R6 to at R0. So first you have to take that R6 value to A. From A, you can store it to R0. So that now when you compile this and this, you can see the answer in the memory locations also. So those who are not interested to show the answer in memory location, you can refer the program of the first. This part you can ignore. I am doing additional part now. So I am giving two datas. Same data I am going to give. What are the data I had given? I added A5 and 85. If you're writing modify using this one, you have to write 0x, 0AA you have to give. Starting you have to give 0. Whenever you want to give data greater than 9, 0AA you have to write. If you write right click modify data, no. Otherwise double click and you can change the data. Double click on this and you have to change the data. So now you'll get here 1, 2, here 1. Answer is 2A and 1. 2A should come in this location. 1 should come in this location. Let us check. Okay, 2A came. After that increment R0. So R0 is 36 now. It is going to 36 location. Now we have to pass accumulator value. Accumulator is here. What is that? 2A. 2A will come to this memory. See, this sum is came here. And carry also you can move it. If you check for carry. If there is no carry, by default 0 is already there. Now its carry is generated, no? So R6 is incremented by 1. Increment R0 and move A comma R6. R6 value is taken to accumulator. From accumulator we have to move to. So now you can see 2A is LSB of sum and carry is actually just stored in next location. So A5 and B85. A5 and 85 are the two datas and sum and carry are actually stored in the memory location. All the data outputs also you can verify in the memory location only. But in the program, they ask you to store the result in R5. So in R5 also, you're going to see here. So R5 actually here only you have to store. So let me add here only. Move A comma R not now. So here only you have to do because here A value is changed now. So what you can do is move A comma R5. You can add that sentence there only. Mm, move. That is left to you how you are writing the program. Because here I'm taking R6 value to accumulator, so you can avoid this. That is left to you. So start debug. Eight five 85. You can verify answer both in memory location as well as in, see it's coming in memory location, and even also you can see the result in R5 also and R6 also. Okay, thank you.